This video is brought to you by Sporlan, quality, integrity, and tradition. What we have going on today is we have a smart hood system, an existing smart hood system that the customer no longer wants to use. They want us to completely bypass it, so we have to disconnect everything and wire in conventional motor starters and controls, including the touchpad. And all this with a fully functioning restaurant that's operating and cooking. So we can only do it in little pieces. You can see we're starting to pull everything out, but we have to have a fully operational hood today and every day that we come back. Because nothing is labeled, we are identifying these stat wires that used to be occupied signals to the ACs and CO2 sensors, or CO2 signals, so that way the IntelliHood system knew to ramp up or slow down. So we labeled those in all the ACs. They're disconnected for now. And then we're just gonna put them up into here. We're just clearing out stuff because there's no schematic telling us what's what. So we're having to go through and identify every wire. So it's just time consuming is all. All right, we pretty much got everything identified with labels. We took our time doing that. We are gonna use this for a giant junction box for all this conduit and stuff. And then the theory is that 4 motor starters on the bottom with a conduit running over to there for the outgoing power, load side, and then a conduit running up here for line side coming in, and then we'll have relays up top and thermostat wire and stuff up top. I bet you anything that's freaking $10,000 to $15,000 worth of crap if it was sold brand new. I guess maybe not. Well, yeah. Those starters, they were, if you bought them through Mailink, they were costing $1,000 each programmed, and that was like 5-6 years ago. So yeah, I bet you we got 10 to 15 grand right there coming out of their hood system. And then now we're just gonna put in conventional controls, which will work better, but. All right, we are back to get a little more work done. So I've got the pre-wired controls package set up here. Just kind of set up a little bit, not perfect. And it's gonna fit right in here. So we're gonna get the speed controllers out and then start getting ready to mount the controls package. The idea is to get the controls package installed with the lighting controlled via the switches right here, and then come back another day and tie in all the exhaust fans. And again, this is my junction box over here, and then we'll run all the wiring over here into the starters. We wired into the fire suppression system, the micro switches, so that way if it triggers, it turns on all the functions of turning on the hoods, turning off the makeup air, all that good stuff. All right, so what we have here, we have that is our junction box. This right here is our hood control box. It's still kind of a mess, but we have functioning starters, functioning light switches all throughout. Fire suppression works. If fire goes off, it eliminates makeup air and AC and just turns on exhaust fans. It'll also turn on the exhaust fans if there's no hood power too. We have it wired up and we just simulated that too. So that's pretty much all we can do for today because it is raining outside. We might, yeah, it's still raining. I can see outside, so I think that's pretty much it for now. We are back again today. We are doing the exhaust fan tie-in. I wanted to put like wire hide all around the perimeter, but it's not really gonna work out, so it's not gonna be as pretty as I'd like it to be if it was like a professional panel, but whatever, it is what it is. All right, well, look at that. We'll clean it all up, but we're getting there. We're getting there. Looking pretty good. We're in the process of testing the phase rotation now. So we've got them all tripped and we're gonna do them one at a time, testing phase rotation. All right, that is it for today. We have fully functioning operating hoods based off of the switches. Now, I still have a little bit more work to do. We got to clean up this box over here. It's like a giant dumpster fire in there, but we'll clean that up. And then what we need to do is we need to tie in their makeup air. Their makeup air is called capture jet fans. So what they actually do is they have these little holes right here, and what it does is it pulls it from over here. That return grill, there's a fan in there, an inline fan, and it just blows it in here. So this particular prototype, or this particular restaurant, they don't have a dedicated outside air makeup air unit. They actually pull makeup air through all the ACs. So that is one downside to what we're doing right now, is they run into air balance problems, but we try to throttle it by opening outside air dampers. Whatever. That's a problem for corporate to make a decision on, because they'd have to completely redo their hoods to add a makeup air to the building, or potentially dump it in the back of the kitchen, which creates a problem. So that's a problem for another day. We still have to tie in the capture jet fans, the inline makeup air fans, into the relays. And then we also have to tie in the occupied signal of the ACs into the relays. We are tied into the fire system though, so that is good to go. So yeah, we'll be back hopefully tomorrow to dial this in and finish it up, and then I have a schematic for him that I'll put right here to make it easier for the next guy, and then I'll get a new label maker because I ran out of labels and or whatever. That's a long story, but and then we'll label everything correctly too. So we're almost done. All right, I'm back. I'm not super happy with like the organization of the panel, but it's about as best as I can do when you have a fully operating system and you know you're limited on time. If I could build this in a panel shop, I can make it all pretty, but it is what it is. So we're wiring in the control wiring. I wired in the makeup air units, which is, remember, the capture jet fans that I talked about. So I wired those in, those are set up now. And then now I'm wiring in the fire shutdown with these two relays and the AC occupied signal. So that way the ACs all get forced on when the exhaust fans turn on into occupied mode, so the indoor blower motors run, because we have no makeup air unit, right? So we need those ACs, blower motor running, and the outside air dampers opening, so that way it can bring in fresh air, and then the capture jet fans can circulate it and create an air curtain. So that's where we're at right now, just doing one AC at a time, wiring them, and then hopefully we'll be getting closer to being done. Here's my thermostat wire coming up. We have the red wire going to R, the black wire going to the smoke detector input. So if there's a fire shutdown via the fire relay, it sends 24 volts from this R up to here and does emergency stop on the unit. The unit also still has a smoke detector that does emergency stop, so either way. And then you also have 24 volts coming up as an occupied signal going to OCP. So this unit can go occupied if the thermostat calls for fan, and it can go occupied if the hood system gets turned on. And we're gonna do the same for every other AC. All right, we are all set up. Everything's cleaned up, you know, as best as possible. Again, this is not perfect. I would love for it to look prettier, but it is what it is. We're all wired in, everything's labeled, it all functions. I've got labeling all right here, labeling all the fans, but then I drew out a schematic showing my whole setup here, exactly how I did everything and what controls what. It's tied into the ACs, it's tied into the fire suppression system. So now, normal operation, hood power comes on, motor starters all turn on. As long as there's not an overcurrent situation, it turns on the motors. Also, when you turn on the hood power, it turns on makeup air units, which runs the capture jet fans, turns on an AC interlock relay. If there's a fire situation, fire suppression goes off, micro switch at the fire suppression system shuts off these two, turns on these two. This sends a signal to the ACs to do an emergency stop. Then, if everything is off and nobody's in the building and fire suppression goes off, these two are energized. All the exhaust fans turn on, but the makeup air and the AC interlock do not turn on. You know, and it runs that way. So that's the typical hood setup that we've done. Now, in hindsight, how would I do this differently? When I pulled everything out of this box, I would run that wire hide all the way around the perimeter. And in fact, next one that I do, that's what I'm gonna do. Run the wire hide around before, and then maybe even one in the middle. And then that way I can hide all the wires inside the wire hide. Potentially, that's what I'm gonna do next one. I've already got another one scheduled, so that is it on this one. These are really difficult to film in the way that I want, and this didn't turn out like I would have liked it, so I apologize for all the clips and the cuts and everything, but you can only do so much when you're really in depth. Now, when we're doing these, we have a fully operational restaurant, okay? I prefer not to do night work. I don't like doing night work. I'm too small of a company to come in overnight and deal with this. Plus, it costs a lot of money, overtime rates and all that stuff. It just doesn't work for me, okay? Because if I do night work, then I can't work tomorrow. If I and the way that my company policy is, the way that I run it is we have to have 2 technicians on site. We're not sending one person to be at a restaurant all night by themselves. That's not how we do it. No offense to anybody else that does it that way. It's all good, right? I just don't. I always have 2 people in the building, whether it's me and another tech or me and a manager or something like that, okay? So in hindsight, you know, in a perfect world, if we came in overnight, we could probably get this done in 2 nights. Okay. Probably actually 1 night, to be honest with you. Instead, we do it during the day when the customer's on site. So we basically get there whenever they get there in the morning, typically 7 a.m. You know, sometimes we'll have them come in early, but 7 a.m. And then we work until about 10:30 a.m. at the latest. This particular customer opens at 11 a.m. So we got to give them time to be able to heat up their appliances and get everything going. The entire time we're doing this process of removing the old system and partially installing the new system step by step, again, like I reiterated in the beginning of the video, we have a fully operational hood. So all their exhaust fans are running, all their lights are working, everything is functioning. So we have to do this in stages, little bit at a time, okay? Once we do that, you know, we install everything and then we test it. Now, it helps to have someone that, you know, working with you that knows the game plan and what's going on. This really is a 2-person job where you can send someone else to go do something and then you're focusing on one thing. That's very important with this, and it speeds up the process. I've done a bunch of these, and the first couple were a cluster. They were a disaster, right? And then you start figuring it out. Biggest thing is, though, is understanding the way that you want these hoods to operate. Now, always consult your local fire codes and different things like that. Every location, every municipality, whatever, you know, who knows? You always want to make sure that, you know, you're doing what's right. And you want to make sure that you're up to code and everything's operating properly. Now, the way that I have this system set up, like I mentioned in the video, normal operation, someone goes and turns the hood switch on, all the exhaust fans, the makeup air, and the AC interlock or the AC, you know, relay turns on. Now that AC relay sends an occupied signal to the ACs, opens up the outside air damper. It also sends 24 volts to the G terminal, turns on the indoor blower motor. So that way, anytime someone comes into this building and turns on the light or the power switch for the hoods, all the AC's indoor blower motors turn on, run full speed, and the outside air dampers open up. Now, something to remember, I am in a dry climate, okay? Can't be doing this in a really moist, humid area because you run into some serious problems. We're in a dry climate. That's the way that we have to do it. Now, to add a real makeup air to those hoods, they would literally have to just do massive constructions. The hood, you know, they don't have a dedicated makeup air on the roof. It's a nightmare. Another thing, well, anyways, let's get back to the operation. So then you turn on the hood switch, all the starters turn on, permitting that there's no overload conditions. The motors turn on, the makeup air turns on, the ACs go into occupied mode, the system operates, okay? If there's a fire in the building, there's a micro switch in the fire suppression panel. If someone pulls a pull station, or if a fusible link melts inside the hood because of high temperature, the micro switch is actuated and it forces my AC and my makeup air unit off, but it forces on the exhaust fans. If they're already running, then they just stay on. If they're not running, then they turn on. The theory is that if nobody's in the building, exhaust fans get turned on, suffocates the fire, slows it down until the fire department gets out there and helps, okay? We're closing the makeup air units, kind of like a fire damper, so that way, or we're closing the outside air dampers on the ACs, so that way there's no incoming air source, right? Because if nobody's in the building, all the doors are going to be shut, and you just got the exhaust fans running, putting a massive negative air pressure on it, slowing it down until the fire department gets there, and then the fire department would take over and do what they have to do. Or maybe fire suppression is going to put it out. Again, you got to pay attention to your hood manufacturers too, and how they design their hoods with the fire suppression system. There's a lot of different variables. This isn't my creation. I came up with the schematic and how to wire it and everything, but I was told to do it this way, and this is how the customer wants it done. And their engineers have spec'd it this way. So, you know, I'm not signing off on this. I'm doing what I'm, you know, was told to do as far as what the customer's requirements are. Okay. So, that's the operation, of how we have this one set up. It is a fun job, but it's a lot of work, and it's kind of a high stress thing because, again, you've got an operating kitchen, you've got people walking around, you cooking the whole time. It's rather difficult to move on with that stuff. So we try our best. I'm not perfect. You know, I would love for that panel to look a lot prettier, you know, but it is what it is, you know. If I was getting a professional panel made, of course it would be all nice and neat, you know. But again, I try my best, all right? I really appreciate you making it to the end of the video. Thank you so very much. If you haven't already, please consider checking out my website, hvacrvideos.com. Merchandise available on there, including these hats, beanies, sweaters, sweatshirts, t-shirts, all that good stuff. Stickers, everything's on there. That's a great way to support the channel if you're interested in doing so. There's some other ways to support the channel, but the easiest way is simply watch the videos from beginning to end. That really is the easiest way. If you want to go to TrueTechTools.com, I have an affiliate link set up with them. Big picture, one word. If you use that offer code at checkout, you'll get an 8% discount on majority of the items on their website. Not everything, but majority of the items, and I get a small commission from that. You can also support the channel via PayPal, Patreon, or YouTube channel memberships. Those are all different ways that you can help to support it. Again, thank you so very much. I am going to be at the AHR trade show here coming up in about 9 days. And that is going to be in Chicago. If you guys are making it to the show, definitely come by the Parker Sporlin booth, the Refrigeration Technologies booth, or the Heatcraft Refrigeration booth. I will be more than likely at one of those 3 booths on Monday and Tuesday, and then Wednesday I'll probably just be walking around the show checking it out. Pay attention to my social media. If you're going to go to the AHR trade show, I'll be announcing where I'm at. If you wanted to come by and stop me and say hi. If you see me at the show, sometimes I walk with a mission and I don't look approachable. I don't know how to turn that off. All you got to do is walk up and stop me. Just say, hey, if I'm talking with someone, politely come up and, say what's up. I don't mind. That's what I'm going to these shows for, is to say hi to people. So don't not say hi to me because I look like I was busy or something like that. Come over and stop by and say what's up. All right. I really appreciate y'all. Thank you so very much. And we will catch you on the next one.